Good morning. We have a special guest with us this morning. We've got Albie, who is harassing me to no end a couple minutes ago. So I figure I'll do as much as I can with him unless he gets annoying. If his purring is drowning out my talking, then let me know and I can put him down. Not kill him, but place him on the ground. Yes, but I think I'll keep him up here for a little bit because he's going to annoy me otherwise if I put him down. Yeah, so welcome back. Hope you've all had a good week. This week was a really good week for Jugglebot, I think. I've gotten through a few things that I was kind of putting off a little bit, but they're all working now, and yeah, I'm keen to show you all what's been happening. But first, I actually have a very exciting update, well, not really update, but thought regarding the AI robot control of Jugglebot. So this is something that I've mentioned a little bit in the last, since I've been like making these videos, really. I've noted that I'm fairly confident that an AI controlled Jugglebot will be able to do better than one that I code, like go here, throw, go here, catch, etc., etc. And I saw a really interesting video, I think yesterday, by 2 Minute Papers, and there's a link in the description to this live stream, to this video, which I strongly recommend everyone watches, because it's so good. These people, I think they were from Google DeepMind, they made an AI they trained an AI to control these little like walking soccer playing robots, and it is really, really good. It is significantly better than the ones that they like control themselves. Granted, there are way more degrees of freedom with these robots than there are with Jugglebot. These have 20, if I remember correctly, but Jugglebot has 7 right now. So it's maybe more feasible that a human-controlled Jugglebot would do better than a human-controlled, whatever you call these, little soccer-playing humanoids. But I think that the general theme still applies. And after seeing this video, Albie's done. After seeing this video, I feel much more confident that an AI-controlled Jugglebot would be so good. The only issue, of course, is that I have never done anything with AI control, and so that's like a whole can of worms that we'll have to go through eventually. And now he wants to go outside. Go on. Get out. Cats, eh? Yeah, so I really like this video. I strongly recommend you watch it. It's really good. And while you're watching it, have in your mind, what if this was applied to Jugglebot? Like, it's gonna be so good. Yes, another quick update is, I meant to change this. Sorry, I meant to change it to Jean-Marc's joints, not just Jean, but I got distracted. You may remember from, I think it was last week, I was showing off some joints that one of the people on Zulip is particularly interested in. And Jean has found a new joint for us, or Jean-Marc, I should say, sorry. He found this like flexure joystick controller thing, and I printed out the model for like the bit where it says weird flex in that image. And this is really, really cool. So to give a little bit of backstory on this, let me show you on the actual robot. There's a little bit of spoiler in here for something I want to show you in a sec, but that's worth it, that's okay. These joints down the bottom of Jugglebot, and also at the top. So like these joints down here, and also the ones up here, are basically like ball joints, essentially. One of them is a ball joint, and the other one is like a ball joint with the twist axis removed. And I am a big fan of compliant mechanisms, and I would really like to add compliant mechanisms somewhere into the robot. I think the best spot would be for these joints down the bottom. So these need 2 degrees of rotational freedom. They need to be able to rotate like this way and this way. Right now, they are metal magnetic ball joints, and they work, but it's very opaque. Like these bellows that I have around them are there to stop this like twisting rotation, which they do extremely well. But because they are opaque, you can't see the ball joint inside, and so you just see this thing, and it's like, well, what's in there? And I don't really like that. I want it to be open and really clearly visible as to what's actually going on. So I'm in the market, so to speak, for a replacement for those joints. And Jean has taken a particular interest, or Jean-Marc has taken a particular interest in compliant mechanisms, which I love, and has been looking around for different options. And this one has exactly those 2 degrees of freedom. So it would have this rotation and this rotation. And you can obviously combine these together. And it's kind of hard to show this on camera, but it can do the full, like both degrees of freedom. Obviously this print quality is kind of crap. I don't know if you can really see it from a distance, but yeah, my printer could do with some tuning, but it still works. And yeah, I really like this design. It's very good. It's solid. I think that for me, if we were using this for the joint that I just showed, I think we would want to change the form factor of this a bit. Like I've completely just taken this straight from the model here. So there's all these like weird other add-on bits that we obviously don't need. And I don't know if I like the general shape of it, but like the compliant mechanism structure part, super cool. I really like it. Even cooler, in my opinion, is Jean-Marc has designed his own compliant mechanism. You may remember from last week, I should have printed another one off, but the printer was going like non-stop this last week. Jean-Marc found he designed a compliant mechanism that looked similar to this, and it was the one that actually snapped in the stream. And he's come up with this slightly different design that I think has very strong promise. It looks like it would be a bit tedious to put together, but it looks like it would be extremely stiff when it is together. So one disadvantage that compliant mechanisms often have is that you can often move them in a way that they're not supposed to move. So this is only supposed to be able to move with these 2 degrees of freedom. Like it shouldn't be able to twist, or like twist this way, which it does do a very good job of resisting. But if you can see, there's a slight gap beneath this peg and the bottom, and I can compress, it's a little bit wobbly, but I can compress that down so that it flexes in a way that it's not supposed to flex. And I mean, that's not a very large, it's not a very large deflection in that direction, but we really want like as little as possible. And I think this design that Jean-Marc has come up with would be pretty good at achieving that. In case you can't really tell what's going on here, this little cylinder off to the left is an example of one of these rollers, and around that cylinder is wrapped 3 like sheets. I don't know what we could use for them, but he was suggesting cable ties in a similar design, so maybe cable ties would work, but it'd have to be something quite flexible. And the idea is that like if this cylinder were to rotate in that direction, it would wrap up the purple sheet and unwrap the yellow sheets. And obviously rotation in the other direction is the opposite. And if we combine this into this kind of like big arm mechanism, as the arm rotates clockwise and counterclockwise with respect to this lower part, those sheets will kind of wrap and unwrap around those cylinders, and it should keep it all extremely tight. And I'm very keen to see where this goes, if anywhere. I think it's a really, really clever design. Yeah, I would be very, very excited to see this in action. Relatedly, Jean-Marc, I spoke with Jean-Marc about what I could name this segment, because this is a bit of an ongoing thing now that he's taking such an interest to the compliant mechanisms, and because I have such a love for compliant mechanisms, I want to move this aspect of the project forward, even though I don't really personally have as much time as I would like to dedicate on this, because like realistically those joints are pretty good as they are. Like the only real gripe that I have with them is that they are covered, and also the fact that those bellows around them are really annoying to print. The TPU has to be extremely dry for that to print nicely, and some of them have actually broken, so I need to reprint them, and I'm really just not really looking forward to that. Yeah, so compliant mechanisms would be great. All of this said, if anyone watching has an interest in compliant mechanisms, strongly recommend you to check out the, I think it's in, I can't even remember what stream it's in on Zulip. If I remember, I'll add a link to the description of this live stream after I'm done recording to where this topic is on Zulip, and you can have a look, you can have a read through. It's getting to be a pretty developed conversation now. And yeah, if you have any thoughts at all on how we can design a 2 degree of freedom compliant mechanism with like as little slop as possible, we would love to know. It's a very exciting area of Jugglebot research, in my opinion, even though I don't have as much time as I'd like to spend on it. Cool. So, on to the actual updates for Jugglebot. Jugglebot is finally moving. It is extremely exciting. I'm very, very happy for this. I have been very nervous about turning it on, and yesterday when I was doing all this testing, I had my hand over the e-stop button for a lot longer than I probably needed to. But I'm very glad that I did, because I almost broke Jugglebot, as I will talk about in a sec. But first, I want to take you on a very quick tour of what the robot looks like now, because I've made some small but meaningful to me changes on the robot. I don't know why this camera is so droppy. I need to look into that. The biggest change that I've made since last week is, let me zoom in a bit so I can show you a bit more properly. We have now proper ports for connecting to the robot. So before, I just had these two cables, the power and the CAN cable were just kind of dangling around, but now they've got this nice little hub. And soon, hopefully, I should be having a new regen clamp arriving, which I'll talk about a little bit when it matters. So these cables will all be nicely covered with this black sheath. They'll look all crisp and beautiful. I've tested out covering the CAN cable plus the power cable that will go off to the arm and wrapping these all together in this like black sheath stuff, and that works extremely nicely. I am very happy with how that looks. Of course, routing the power alongside the CAN communications is not what you're really supposed to do, but I don't really see any other viable option right now, so this is what I'm going to do. And I think it looks very good. So that's going to be running up to like up here. I've got more of this like black wrapping stuff coming next week, and hopefully I'll be able to get all that together and it will look schmick. One funny story actually, so I've got these power cables set up that will run up to the hand, and yesterday when I was powering everything on and doing everything, like I've connected all this up to these bus bars in the middle, and I kind of just forgot that those power cables are dangling, and so I had like 48 volts or 45 volts running through these while I was doing other stuff, and these two terminals were just kind of like dangling, sitting around everywhere, like wherever they happen to be. So that was not great. I almost shorted the circuit or zapped something else depending on where they happened to land. But thankfully that didn't happen, and I noticed before they zapped anything, so it was all good. Yeah, so like relatively minor updates, but I just love how, where are we, this one? I love how nice this is all looking. I'm contemplating, I think once I get like finalized on everything, I think I'm going to cover these yellow, where can you see one? There are these yellow plugs around the place that connect to the motors. I'm thinking of covering up those with like either heat shrink or the same wrapping stuff, just to make it so that it's everything down the bottom is all black and everything above that's printed is red. Nice and color coordinated. It'll be so good. Okay, so now let's have a look at Jugglebot moving. We have the GUI as before, that hopefully you remember from all those weeks ago. And let's turn it on. It's always a bit nerve-wracking turning it on and getting it set up. I don't really know what view is best to use here, so if you want to see a slightly different view, let me know. I can get rid of myself. Yeah, we don't really need to see me. Where am I? This one. Goodbye. Yeah, one thing that's noteworthy, I guess, for anyone who's doing a similar sort of project, is that the ODrive 3.6s had this routine. So the old motor controllers that I was using had this routine where as soon as you would power them on, I will bring myself back. As soon as you power them on, they would go through this sequence where they would run the motor a little bit until the motor ran past a certain point relative to the encoder that's attached to the motor. And they would do that as soon as you power them on. It would always just by default. The new ODrives, the ODrive Pros, don't do that, and I had to manually put in a thing so that when I start my like Jugglebot code, it does that automatically, which was a little bit weird that one of them does it. Like they do it very differently, but I don't know. I guess that's just what they decided to do. Let's get rid of me again. No. So, yes, we've turned on. They've all found their indexes, so now we can home. So all the legs will shrink. This runs way faster now as well. I haven't changed this code at all. It just runs so much faster on the ODrive Pros than it did on the 3.6s. And I don't really know why, but it does. And we can go to Space Mouse Control. And now I can move it around. And it's great. Let me fix the camera up a bit. Yeah, so it's functionally the same as it was before, really. Which may not sound super exciting. I've turned it all around so it's not facing the same direction as the Space Mouse, so I can't really control it in the ways I would like. But yeah, it does everything it could before. Which I guess isn't super exciting, but it's exciting for me because it means that it actually works now and doesn't break itself. And now I can go end session, and it closes. No more errors. Look at that, beautiful. Actually, there was some. No, that's fine. Those errors are fine. Yeah, great. I love it. It's so nice. E-stop, kill it, gone. So good. Yeah, it's definitely very, very nervous yesterday. And to give you an indication or I don't know, a bit of the experience as to why I was nervous, it's because I almost broke all 6 legs several times yesterday while I was changing my code over to run from the ODrive 3.6s to the ODrive Pros. And yes, my problem was that in the homing sequence, so let me explain this fully. During the homing sequence, the robot will move each leg into like one at a time. I do have thoughts about doing these all simultaneously, but that's a separate thing. Right now, they go one at a time down until they hit their end stop, and there's like a little bit of foam padding to kind of not make that too harsh. So they run down, the current will spike in the motor because it's hit the end, and then when that current spikes over a certain level, the ODrive says, yep, cool, you've hit the end stop, and now, so that we don't hit the end stop again during normal operation, let's set the 0 point of the actuator to be a little bit above where we are right now, where we have registered being the end. So we move that end stop just up a little bit. This is important. The way I was doing this before is using this function, I guess method, whatever you want to call it, called set linear count. And this was in the encoder frame of reference, which has 8,192 counts per revolution. However, set linear count is not a thing in the new ODrive firmware. It is instead set absolute position, which is in the motor frame of reference, which has 1, like the number 1 corresponds to 1 revolution. So 0.5 will be half a revolution. And I was telling previously when I was using set linear count, I was setting the offset as being 1200, just because that felt like a, I don't know, just a random number pretty much. That was a little bit. So it would previously move so the encoder was 1,200 counts off of where it currently is, which is much, much less than 1 revolution. It's like a 1/7 of a revolution. But of course, now that I've changed it, I probably should have just read the documentation a little bit more thoroughly before doing this, but I just literally changed these words here. They were previously set linear count, and now it is set absolute position. So it was thinking that, oh, cool, I'm at position 1200. And it was like, yep, cool, that's fine. But then when I would send the next command of move to position 0.5 or whatever, it would go, oh, I've got a long way to travel before I get to 0.5 because I'm all the way at 1200 right now. Thankfully, the speeds were set low enough that I was able to, and I had my hand on the e-stop, and I was able to see like, okay, this is going a bit higher than it should, because normally at the end of the homing sequence, I have it set up so that it raises up a little bit, just like off of the bottom. But it just kept going. And that happened probably 3 or 4 times before I finally realized that this was the problem. And yeah, there were a couple times when it hit the end and I could tell that the motors really wanted to keep going, but thankfully I got the e-stop just in time. So thankfully nothing broke, but it very easily could have. So I guess the lesson is to read the docs when you're changing your code, because yeah, mistakes can happen. And I'm a little bit worried that there are other kind of things lurking around that have changed between the old firmware and the new firmware. I guess we'll find out. I don't think so though. I'm pretty sure this is the only one. But, you know, what are the odds that it's the only one? Anyway, so what about the hand? Last week we were talking a lot about the hand, and actually, last week we were talking a lot about the hand, and I have made some developments to this. So just before I show you what I have done, I want to just elaborate on why I spent the time to fix the Jugglebot code up, and that's because I trust the hand mechanisms that I have right now well enough that I want to start using them over CAN control rather than over USB, because USB is crap. And I want to just if I'm going to do the code to test the throwing, I want to just do it the proper way the first time so that I don't have to port things over from between different formats, if that makes sense. So I wanted to get the robot working so that I can position it in its spot, and then I can test the hand by itself, all over CAN, which would be lovely. So I wanted to get the robot working first before I'm doing the hand stuff. But now that the robot works, we can get back to the hand. So last week, I showed off this design, which is a capstan-based, I guess we could call it, design where there are two strings. One, I'm not going to explain the design. Watch the last live stream if you're interested. But they wrap around the spool here at the end, and yeah, that's how it controls the hand position. So as I turn the spool, it will move the hand up and down. And last week I noted that I had some problems with the hand slipping. And I previously only had 2 wraps on the spool up the end here. And you can see now I have, I think 5 or 6, depends how you want to count it. And honestly, it is significantly better. I really need to get better at trusting the math. This is something that I've had a hard time with my whole life. But yeah, math is good a lot of the time. Sometimes it's not. Sometimes you make assumptions and the assumptions just kind of make everything fall apart. But yeah, in cases like this, the math is good. If you look up the capstan equation, which is what describes the forces and slipping and everything like that with a rope wound around a spool, the amount of friction that is generated by each wrap goes up exponentially. So 2 wraps will have approximately from memory, about half as much friction as 3 wraps, which will have about half as much as 4 wraps. And so each wrap you add massively increases the amount of friction here. So going from 2 wraps, what I had before, to 6 wraps, I can't get this to slip now. So previously I could tilt this hand to get it to be in a wacky position, and I can't do that now. However, I can if I press it in a tilting position and slide it up and down. If I do this a couple times, then it will stay tilted. And then I have to run it back again a couple times to flatten it out. So even though this is a lot better than it was before, and to be honest, I think this is good enough for me to be running, whatever, I can fix it later. Even though this is good enough for me to be, I feel that this is good enough for me to run it as a prototype sort of thing, to just practice the coding side of this, of the hand. It's definitely not good enough for a long-term solution, because over time that could tilt, and the fact that it could tilt is enough to just make it a non-starter as far as I'm concerned. That, yeah, no good. Which is annoying because I really like the form factor that this has. It's so elegant. And I've also cut my CAN cable to match the O drive being here, which is a bit annoying, but whatever. So that's the one from last week. I've also made a second one. I've made one based on belts. And this is extremely similar to John's design, which you will be seeing very shortly. But it's based on belts instead of strings. And this is the first time I've ever used belts for any of my own designs. I built my 3D printer following the Prusa instructions. So I've got I don't know, I don't really count that as a belt experience. But so yeah, let me show you the way that this runs. So the belt is terminated in the hand, which I will get to in a sec, how I've done that. This is just a little thing because I had to change the way that the belt was routed, and in that change, the length of the whole path changed, and it is impossible for me to get the belt out of this hand now that I've got it in, which again, I'll explain in a sec. So I figured that the easiest way to just like remove a small bit of the belt was just to do this, which is obviously a bit dodgy and wouldn't happen in the real thing, but there you go. The belt then runs around the top. There's a second pulley underneath there. These were supposed to be side by side, but I was measuring my pulleys, my idler pulleys, using old pulleys that I had from like an old project. And then but I didn't have enough of those, so I bought some new ones, expecting that the dimensions would be the same, but they were not. So I've had to change the design a little bit to accommodate them. And down the bottom, it just runs around this one large pulley, which previously, again, was two small ones, but same reason they didn't fit, so I just replaced it with one big one. And then to tension the pulley, I'm quite happy with this. I really like how this worked. It's a little bit dodgy because that bolt doesn't sit flat, but the general idea is that this arm can come out, and on it sits an idler pulley, and then to set the position of this arm, like how far out this is, I can grab pliers and hold this lock nut, and then just tighten or loosen the bolt through the hole in the other end. So this, oh, come on, focus. So that bolt just like runs through one of these holes in the linear guide. Yeah, so this, and yeah, around the motor, we've got two idlers keeping tension on there, like that. And my problem is that this is very, like, it's frictiony, it feels. It's not as clean as the other one. Like, for example, if I have this design and I drop the ball in, it easily travels the whole way down, irrespective of where I drop the ball in from. But with the belt, it doesn't. Something is stopping it from sliding as smoothly, which is a bit annoying because I was very hopeful for belts. I'm fully expecting this to be a me problem. One reason why I think this might be happening a bit more than it should is that this linear carriage has actually lost a couple of its balls. That could maybe be adding to it, and maybe this like bend radius in here is a bit too tight, maybe, but I don't know. If anyone has experience with belts, and in particular them not running super smoothly, like it's smooth, but it's not like transparent, I think is the like robotics word, where it has extremely low inertia. I want this to have as low inertia as the string one does. So I don't know. It is cool though. I like how this works, but yeah, I don't know. So that's the second option. And the third option, I will have to change my space mouse over. I need like a dedicated Jugglebot space mouse. If 3D Connection wants to sponsor me, I'm all ears. We've also got a third design, which is John's design. I don't remember where he's put it. I think in here. Yeah. He made a very cool... Oh, I'm on the wrong screen. There you go. So John on Zulip has made this. Why is my space mouse not working? Oh man, I've got to use my mouse like a fool. Hang on, give me 1 sec. I feel like it should be there. Oh, it's one of the tabs down the bottom. I'm starting to get familiar with Onshape, and it's definitely taking a little while. So John's, sorry, I'm going to be very clunky because my space mouse isn't connecting properly right now. But John will show this off more properly in the working session. We're going to have a good talk about the different hands and this sort of thing. But just to show you very quickly for anyone who is not going to stick around for the working session, John has used a linear guide rail, the same as what I have here, except he's added it to a backbone using a 20 by 20 aluminium extrusion like this. And I was originally a bit hesitant about this because of the added weight that would add. And as far as I'm concerned, this linear rail is extremely stiff. This is only a really short one right now. This is the only one that I have on hand, but I have ordered some significantly longer ones, but they're probably not going to be here for like another 2 weeks or so. So I'm just doing like a little tiny shorthand for now. And yeah, when I was feeling this around, I was like, yeah, the linear rail itself is so stiff. Like there's no way it's going to have any issues with like flexing or anything. But John did have a very good point regarding vibrations, which is something that I have not really considered too much because I just haven't been working at those sort of speeds yet. But I have every intention of bringing Jugglebot to the point where it is doing things like throwing 7 balls in one hand just to itself. And if I've learned anything from my over a decade of juggling, it's that is extremely fast and a lot of power has to be going through the hand during that process. And at that level, it is pretty likely that vibrations will start to play a role and will start to be an issue for a design like this, where I'm only using a single linear guide rail. So I do think that John's idea of adding this like aluminium extrusion backbone is a very good idea. Is the space mouse going to work? Nope. Okay. Yeah, I'll let John explain this himself more fully. It's similar to the belt design that I have here, except he's using strings instead of belts. But yeah, I'll let him explain it more fully. So yeah, if anyone knows why my belt is so firm, I don't know. It could also be like a low quality belt thing. So I have a belt from a very, very old printer that I took apart years ago. And I didn't know what size that belt was, so I bought some new GT2 belt on Amazon. It turns out they are the same. But I've noticed that the old belt, the one from like a 2014 printer, was extremely stiff, and I could push it through channels a bit more easily. But this one is really soft, and it was really hard to push through the same channel. So I'm wondering if it's just like a belt quality issue. But I don't know, I would think that the softer belt would flow even more freely than a stiffer belt. So maybe it would go in the other direction. I don't know. Yes, another question is I'm curious to know if anyone has any ideas for terminating the belt. Because what I've done is, I don't have SolidWorks open, so I can't show you right now, but inside the hand, so this is the first one that I made, inside here are 2 channels. In this design, those channels run like an X, so there's like one going that way and one going that way, and there is a skinny part, a narrow part of the channel, and then it widens up to a thick part. And my idea here is that I could feed the belt through, fold it over on itself so that the teeth are kind of like intermeshing, and then pull it back through, and then the part where it's folded over will be sitting in the thicker part of the channel, and then it will be too thick to fit through the thinner part of the channel, and so it'll be stuck, and I won't be able to pull it out. And it worked a little bit too well. That little end of the belt there, I have pulled, obviously when it was full, I've pulled on that as hard as I possibly can, and it is not coming out. Which is a good thing because it's secure, but it's a bad thing because I have to do shit like adding this little thing in here when I measure the length of the belt wrong, because I cannot edit it once it's in there. So yeah, if anyone's got ideas for how to do that, I would be all ears. Especially because to get it to work with the slightly revised design with these like 2 channels, I had to actually sew the end of the belt together because I couldn't hold it myself in my fingers and pull it at the same time. So I had to sew it, which obviously took some time. It was a bit tedious. And yeah, I'm very open to different suggestions on this. Yeah. And yeah, John's design is great. I meant to do this in a slightly different order, but whatever, you get the idea. So yeah, that is it. So damn close. I know I've said this for like the last month, but man, it's so good. I strongly recommend, if you are interested in this, stick around for the working session stream, because John will, well, we're going to have a good chat, and I don't know what stage John's setup is at right now, but he has sent some really cool videos to Zulip where he's gotten like multiple throws and catches in a sequence where it just keeps going. So very, very promising, and he's had, yeah, it sounds like he's pretty confident that this something in here can work, and we just plonk it on Jugglebot, and then off we go. We're good. We're done. For now, for one bot, that is. One other thing that I would be remiss if I didn't mention is last week in the working session, we modeled this little synchro mesh spool, and I was actually surprised that this printed. The purpose of this was to operate in the same way as the capstan on here, but instead of using this string wrapping around the spool, we would use synchro mesh cable. which for anyone who's unfamiliar, looks like this, where it's got this like, there's like a wrap around the wrap. If I can show you a bit more properly. There's like a black wrap around the main steel wrap. And we were thinking that if we can model a spool that has little grooves in it to fit that synchro mesh, then maybe it will slip a lot less. And I think that that idea has promise, but I think that the dimensions would need a bit of tweaking because this one doesn't quite fit super nicely. And I think that the spool, I think the spool would really benefit from being a bit larger than this. But unfortunately, I can't go too much larger because of the motor that we're using for this context. So the motor really wants a small diameter spool because it's spinning so fast. And yeah, I don't know if this would work super well for this application. So maybe if anyone's doing something similar, I would encourage, and if you're like really, really motivated on using the synchro mesh capstan idea, I feel like this design could work, and I'm modeling it the way that I modeled it, I think could work, but you'd need to do a bit more tweaking on the dimensions to get it to fit perfectly. But it has some amount of promise, but not for me. Or Jugglebot, for now at least. Yeah, cool. So that's it for the update. Hopefully next week, we'll be able to do some juggling. I feel pretty good. Honestly, I'm thinking I'll be using this. So yeah, my plan right now for the working session stream that will follow on from this one is that I want to have a conversation with John, the same as last week, where we've got on like a live Google Meet, and you guys can see and comment on what we're talking about. And then afterwards, my plan right now, depending on what John says, we'll see, is to adapt my belt design to be a string capstan design, very, very similar to John's one, because his one works really well. Because it's using the linear rail, it doesn't have the problem of the hand tilting like my string capstan one does. And it shouldn't have this problem of the belt. Honestly, belts seem a bit annoying to me. I can see how they are, like they're definitely a much better long-term solution because the belt won't stretch as much as the string will, but they're a lot more annoying to work with. You can't terminate it as easily. You got to route it much more deliberately. You've got to use like the geared pulleys, and I've tried, a long time ago, I tried printing GT2 pulleys on my printer and it didn't really work very well. So I've gone and like bought all these like different sizes. Where are they? Here. So I've got like a bunch of different sized teeth ones, but if I want a size that's like in between two sizes that I have, I don't know what I'm gonna do. I don't know. Yeah. But I think a string will work a lot better for now, at least, until I figure out whatever the issue is with this belt, or if someone has an idea of what it could be. Which, ironically, so yesterday when I was doing the testing on actual Jugglebot, I noticed that a lot of the strings in the linear actuators have gone a little bit loose. And I think this is from them homing all the time and just like ramming the strings into the end. And I actually think that a belt would be a much more appropriate design for the linear actuators because they don't need to be super transparent. They can have a bit of stiffness and a bit of inertia to them. But I do not want them to stretch, which is compared to the hand, which I don't really mind. I feel like the stretching is not going to be as big of an issue on the hand because it's not going to be pushing as hard as the legs will, or like with as much like force as the legs will, and it will be easier just to tweak one hand string than 6 leg strings, or 12 leg strings actually. So yeah, I'm kind of thinking of like reversing this, where I have the string on the hand and the belt on the legs, but I'm not going to change the legs for a long time. That's too much messing around. But yeah, cool. All right, so I will start up the working session stream in a couple minutes. I just need to get set up with John on the Google Meet, and yeah, I'll see you all soon. If anyone's not sticking around for the working session, totally fine. I will see you next week when hopefully, fingers crossed, fingers toes, everything crossed, hopefully we can get some juggling going. I'm very excited. Yeah, until then, have a good rest of your week and good luck with everything you're doing.